Back, ladies and gentlemen. We're going to be taking a look at the physics turtle. Pretty much one of the most difficult questions. That's not true, actually. There are a lot more difficult questions, but it's one of the first difficult questions. And mostly that comes down to the wording. I mentioned earlier on that, starting questions will be very clear. They'll be very explicit about what they're trying to tell you. They'll say stuff like the acceleration is 4 and the velocity initial is 2. What is the velocity final? Stuff like that. Like, it'll be very clear what it's asking for. This question is a little less clear. This question requires you to be able to tease apart the problem, to understand what it's doing. This is what I mean when I tell you guys that this is about learning how to study the world, because the world is not so clean and organized. It doesn't always just have velocity numbers and acceleration numbers just plastered on things. You've got to be able to figure out what information you need to be able to solve the problem. So our physics turtle is moving with a constant acceleration along a straight ditch. He starts his stopwatch as he passes a fence post and notes that it takes 10 seconds to reach a pine tree 10 meters further along the ditch. As he passes the pine tree, his speed is 1.2 meters per second. How far from the fence post was he when he started crawling? There's a lot of information here. So first things first, let's check what the question's actually asking for, right? We see a question mark. That's a good sign. How far was he from the fence post when he started crawling? Started crawling. How far? How far is a question of D. So we're looking for D in this question. But started crawling is important. It's subtle, but it's important. It tells us that initially he had 0 velocity, but that it was some distance away from the fence post. Interesting. We're going to need a picture. This is probably the first question that really needs a picture. So this is going to be page 4, I think. It is number 10. So what are we looking at here? All right, turtle is moving with a constant acceleration. That's going to be critical. Along a straight ditch. He starts his stopwatch as he passes a fence post. All right, so we need a fence post in our picture. So here's our fence post, and here's our physics turtle. Kind of looks like the physics turtles on roller skates, but you know what? If you wanted good art, you go to art class. Physics turtle, and he's going to start his stopwatch right there. So we're going to make that like time equals 0. It then says that at 10 seconds later, he reaches a pine tree. So I need a pine tree. Here's our pine tree, or at least half of one. And it says that this is going to take 10 seconds. Time equals to 10 seconds. And that the distance separating these two is 10 meters. As he passes the tree, his speed is 1.2. Okay, so as he passes the tree, so that means that the velocity over here is 1.2 meters per second. And we'll say that it's positive to make it easier. Finally, it asks you, how far away from the fence post was he when he started crawling? So that means somewhere over here, the turtle started. And we want to know what this distance is. Now, there's one more thing I haven't put on this drawing, and it's a very important thing. Constant acceleration throughout. So this entire thing has a single acceleration value from start to the end. Okay, there's our picture, and this is a lot of stuff here. I mean, at the very least, we've got ourselves a turtle and roller skates. But how do we do this? Well, if this is enough and you think you can try the question now that it's being drawn out, go ahead, pause the video, try the question, see what you can do. If you're still a little stuck, I'm going to keep going. So the big trick, and it's a trick that I keep saying in class and I will continue to say in the videos as well, turn a new problem into an old problem that you already know how to do, break a big problem into a bunch of small problems. There's the tricky one. And every single one of these kinematic equations has 5 variables. So let's start by writing out the 5 variables. We're going to have VI, VF, A, D, and t. Now, there's a lot of stuff we don't know here, an awful lot of stuff. And part of the problem is just that this problem is big. Like, I know a distance, 10 meters, but only for this section, not for this part. I know a time, but only for this section, not this part. I know a velocity here, but not there. I know an acceleration exists, but I don't know what it is. So there's a lot of information that I don't have. But I'm going to break the problem down. And the fence post provides a very convenient break. There's the before fence post and the after fence post part of this entire problem. So 1 and 2. So section 1, section 2. We saw this in the other videos. For section 1, what information do we have? Well, we know that he started from rest because he started crawling. So he had an initial velocity of 0. The final velocity here, I don't know what it is. The acceleration, I don't know what it is. I know he has one, but I don't know what. The displacement, that's what we're looking for. The time, I just don't know. I know almost nothing. I can't solve this. Even with 2 equations, 2 unknown, and heck, even with a bit of calculus, I don't think we could pull that off. There's just not enough information. But let's take a look at section 2. Maybe we'll get lucky. In section 2, we don't know what his initial velocity is. All right, well, that's a question mark. Off to a great start, aren't we? But we do have this velocity, and it is at the end of everything, so that seems like a velocity final to me, 1.2 meters per second. All right, finally we got a number. Acceleration, we still don't know what it is, but we do have a displacement, 10 meters. And we have a time, 10 seconds. And look at that. We have 3 numbers. If we've got 3, we can find the missing 2. What are our missing 2? Velocity initial and acceleration. But why does that help us? Now again, if you think you can solve it from here on out, go ahead, pause the video, give it a try. Check back to see what the answer is. I mean, the answer is also in the book. You can always check there. But if you're still stuck, remember, there is a connection. When we were talking about the other graphs with the motorcycle and other things, we talked about the fact that the final velocity for section 1 became the initial velocity for section 2. The final velocity for section 1 became the initial velocity for section 2. There's a connection between these 2 terms. If I find them in one place, I get to just fill it in for the second. The other thing is, this has the same acceleration the entire way. If I get the acceleration here, it's the same acceleration as here. They also have a connection. So you can see there, if I can get the necessary information in these 2 spots, I can fill in these 2, and then I have 1, 2, 3. I can solve for the missing 2. So that's the key. We solve the part we do know to figure out the part we don't. One of my physics professors back in the day ended up telling a joke basically around this. I assume the joke was a lot funnier in his native language. I think he was German. But he explained a man was stuck out at night. He couldn't seem to find anything. He was looking around on the ground at great difficulty. And some people walking by said, "What are you doing?" He said, "I dropped my glasses. I can't find them." "Oh, well, we'll help you." So they all get down to help look for the guy's glasses. And they're searching for a good 5 minutes, and then somebody sits up and goes, "I'm not seeing anything. Where did you drop your glasses?" And the man gets up and points off into the darkness and says, "Over there." And everyone looks at him funny and goes, "Well, then why are we searching here if you dropped your glasses over there?" To which he said, "There's light here. I can see. Over there it's dark. I can't see anything. Here we have light. Here we have only dark. But unlike the man trying to find his glasses in the dark, these pieces here connect over there, and then we can solve all of it." All right, let's give it a try. We're going to need to do at least a couple equations. We've got dTVF. If we want to get VI, We could use equation 3, d equals vf plus vi divided by 2 all times t. The d is 10. The vf I know is 1.2. The vi I don't know. All divided by 2 times 10 again. So move the 10 over with some algebra. It's going to be 10 divided by 10. That just becomes 1 equals 1.2 plus vi all over 2. I move the 2 over, so we get 2 equals 1.2 plus vi. Move this over with some subtraction. We're going to get 0.8. Didn't I do my math right? Equals vi. Let's double check. I'm pretty sure I did it right, but I want to make sure. 2 minus 1.2, 0.8. Yes, good. I thought so, but it's been a long day, so I wanted to check. So now we know the initial velocity. So over here, I can erase my old number, the question mark, and put in 0.8 meters per second positive, which means over here, I get to replace this question mark with 0.8 meters per second positive. Now that I have the VI, I can solve for the A. I'm going to do just equation 2. VF equals VI plus AT. It's a simple equation, very easy to use. 0.8 equals VI, oops, I got them backwards. 0.8 is not VI. Oh no, it is VI. 0.8 is VI, it's just VI is on this side of the equation. 1.2 plus A, I don't know, and 10, because it takes 10 seconds to go from turtle to tree, or sorry, fence post to tree. So I'm going to take 1.2 minus 0.8. 1.2 minus 0.8. We get 0.4 equals 10A. Divide by 10. We're going to get 0.04 equals A. That is a very, very small acceleration, but I would remind you, it's a turtle. Turtles are not known for being fast, except for the ninja variety. Don't ask. It's an old thing. I'm sure you've never heard of it. So we go in here and we replace this question mark with plus 0.04 meters per second squared. We come over here and we get to do the same thing, 0.04 meters per second squared. And it's positive. So now that we've filled in this information, we can now walk away from section 2 and solve section 1. We now have enough information that we can do that. And remember, we only need D. We have VI, VF, and A, and we're looking for D. That's going to be equation 4. Again, I know this because I've done this a lot, but you have your handy chart that you can check. And if you look at the chart, you will see that equation 4 doesn't have time, and we don't have time. So we're going to want to use equation 4. So we set up our equation. VF squared equals VI squared plus 2AD. VF is going to be 0.8 squared equals VI 0 squared plus 2 times A, which is 0.04, 0.04 times D. So, I'm going to need some calculator for this. 0.8 squared is 0.64 equals 0.08 D. 0.64 divided by 0.08 equals 8 equals D. But now there's something critical that we have to keep track of. The answer is 8. That is true. But it's a displacement. So is it 8 positive or negative? Where are we measuring from? Where did the stopwatch begin? At the fence post. Which means the turtle started walking in the negative. They started over here at -8 and they moved to 0 and then they moved an extra plus 10 to the tree. So this is actually -8. And there you go. That was only 3 calculations in the end. The hard part was making sure to set it up and to understand the connecting relationships between all of these things. Now you have seen how to do the infamous physics turtle. Notice, it's all about breaking things down. It's all about organizing the information. It's all about turning a big problem into a bunch of small problems. At this point, you guys are welcome to continue working on the problems in front of you. You should be able to get up to 15 without too much trouble. 16 onward requires a bit of knowledge of the next set of notes. They're very complicated notes because they involve things falling. That's about it. Gravity exists. Fun fact. We'll talk about it a little more in the very next video. It won't be a very long video. So I will see you guys next time.